All right, so we're starting off with this discussion on powers and exponents. And our primary goal here is to use powers to describe repeated multiplication. For the most part, it's a review. So powers, we ought to remember, are repeated multiplication. For instance, we could take a power, repeatedly multiplying the same thing over and over and over. In our example, 4 times 4 times 4 times 4 times 4. This is a power. We're repeatedly multiplying this number of 4 over and over and over. This part is called the expanded form of the power, and it's not something that we generally do a lot. Instead, we prefer to write it in its exponential form, 4 to the 5th power. And so we will continue with these pieces. With our vocab, what's the base? Okay, with this one, the base is going to be your bottom number in the power. And remember, that bottom number is what gets multiplied. The 4 is repeatedly multiplied over and over and over, so that makes 4 the base. The exponent, instead of being the top number, the bottom number, it's the top one. Remembering that the exponent keeps track of how many times it gets multiplied. For this one that we had in the black, what's the exponent? Yes, it's 5. One part I would like to caution, because it's a piece that a lot of students are a little bit sloppy with and not very careful. A lot of students call the 5 a power. 5 is not a power. 5 is an exponent. 4 is not a power. 4 is a base. The two things combined, base and exponent together, make up a power. It's pretty common that students will make a mistake and simply call the exponent the power. And that's not what it is. You should be careful not to make that kind of sloppy mistake. And then lastly, we'll come over toward here. What's a formula? Formulas are just equations that show some kind of a relationship. And of course, there are many, many kinds of formulas. Some of them that you may have worked with before. We can convert back and forth between Celsius and Fahrenheit, where you can take the temperature in Celsius, multiply it by the fraction 9/5, then add on 32, and that will give you the temperature measured in Fahrenheit. There is a formula that shows the relationship for temperature in these two different measurement systems. Some other really common ones that you've likely worked with: distance is equal to rate multiplied by time. If you drive your car at 75 miles per hour for 2 hours, 75 times 2, the rate multiplied by the time, will tell you the distance you've driven, 150 miles. Another really common one, especially for physical science, the density of something is equal to the mass divided by its volume. These are all examples of formulas. Each formula is comprised of variables, and we know that we can hit substitute in for variables and evaluate. So continuing here, let's start writing some of these powers using an exponent. Starting off with A, what should go in this first box over here?
Power.
Okay, so how many of them? And I've got lots of people telling me 5, saying 5, showing me 5 fingers. Where did that come from? Because we were counting 1, 2, 3, 4, 5. Awesome. Great that you remembered. Let's continue further. Filling this piece in. The base, what's the base? It's used as a factor 5 times. That one's finished. And we can continue on to B. What goes in the first box? We've got 2, because we're simply counting 1 and 2. Thus we'll continue. The base of 0.4 is used as a factor 2 times. Please note, powers apply when you are repeatedly multiplying the same number over and over. You do not have to know what that number is. And that's where we have variables in. We can repeatedly multiply an unknown number again and again and again and still create a power, such as here, 1, 2, 3, 4 times. So we have an exponent of 4. The base of A is used as a factor 4 times. And finish off the last one for me. What's D?
6.
Our base of R is used as a factor 6 times. Now let's start writing some of these products with an exponent. What's the base in the first one?
4.
And the exponents?
4.
Okay, move on. Marcellus, tell me the base in number 2.
4.
Oh. 3. Yes, sir. We've got it so that we have 0.2 for the base. And now we need the exponent. All right, tell me 7. Here's a piece where I'd like to pause just in terms of notation. The way I have this written is correct. 0.2 to the 7th power, it's fine. There's nothing wrong with writing it this way. But when you start looking at math textbooks, they don't normally put this down here. One piece that can sometimes happen just based on notation, is this a decimal, or am I trying to take 0 times 2? Based on the context from the problem we were looking at, we know it's supposed to be a decimal, but because people's handwriting sometimes gets a little bit sloppy, sometimes people will write that down and it looks like they're trying to multiply. And if that's multiplying, that's a very different thing than what we were writing down. That's why it's very common that when people have decimals raised to a power, it's really common to put them inside a set of parentheses. They're not necessary, you don't have to have it, but it's just an added layer trying to let people know, hey, I'm working with a decimal here, don't accidentally read it the wrong way, don't think it's something different than what it is. I'm trying to tell you it's a decimal. You don't have to have them, but it's common to write them down just so that we can communicate with each other better and reduce the amount of confusion. Now let's continue over to this number 3. What's our base? And the exponent? Done. And number 4? Done. Base of y. There were 3 of them, so we're finished. Let's go to this next one. Evaluating. Now, of course, when we did our warm-up at the very start of class, the very first thing we did was look at evaluating here. And we know, based on our previous work, that evaluating means plugging in or substituting a number into the variable, and then we're going to crunch the numbers to see what we get. Well, it's no different here for our notes. What number can we substitute in for x? Okay, and so we have 0.4 to the third power. And we can expand that back outward. We understand that that exponent of 3 is telling us that we have 3 of these. Therefore, we understand we're using this base of 0.4 as a factor 3 times, and our task then is to actually multiply it out. What is 0.4 times 0.4 times 0.4? And I want you to do this without a calculator. What would we get? How would we get it? Okay, so as a review for these pieces, we know that since we have a long string of repeated multiplication, it needs to be done in stages. So we're going to start here with 0.4 times 0.4. And to begin with, we'll just ignore the decimal. What's 4 times 4? Okay, 4 times 4 does give us 16. Where does the decimal have to be placed then? This is one where we need to remember that since we have one digit and a second digit after the decimals, that the decimal has to be placed 2 points inward. So from the end, we come in 1 and 2 places. We actually get 0.16 or 0.16, that is 16 hundredths, and that's the first part. We still have not used that one, and so we have another stage of multiplication to complete. Ignoring the decimals, what's 16 times 4? 64. Okay. Recognizing that it's 64, and even if you needed to go off into scratch to get that 64, fine. Where does the decimal go? Here we have to count. 1, 2, 3. We have 3 decimals. So it needs to come in 3 places. Counting it, 1, 2, and 3. And so we have 0.064 or 64 thousandths. And there, that has gotten us the number we needed. Progressing further and looking at these formulas. So with these particular formulas, here are 2 formulas that are really common to use with exponents. How do you get the area of a rectangle? We know area of a rectangle is length times width. Since the area of a rectangle is length times width, and we know that a square is a rectangle with the sides the same, we can simply do a substitution and note that it's side times side. There's our repeated multiplication. We have our base of s and an exponent of 2. The area of a square is just side squared. Very similarly, we know that the area of a rectangular prism is length times width times height. And we know that a cube has length, width, and height all the same. And so once again, it's repeatedly multiplying. We get this formula for the volume of a cube. Area equals side length cubed. Area of a square is side length squared. These are 2 formulas we will use for our next examples. So consider here. You want to put carpet into your bedroom, and your bedroom is the shape of a square. How much carpet do you need?
3 squared, depends on the
Of course, it's based on here, but we've already got it written up here. We've got our formula, area equals side squared, because it's a square-shaped room. And so what is the base S?
S.
It was our side length of 11. And so we have 11 squared which we know is 11 times 11, and so we have to evaluate the power. What is 11 times 11?
121.
Yes, ma'am, 121. And so we have our answer. The area of the floor is 121 square feet. Let's continue down to this checkpoint then. Evaluate the expressions for n equals 2. What is n squared for n equals 2? Well, we know n squared is n times n.
4.
So when we substitute that, we have 2 times 2, which gives us 4. If we take n cubed, that adds another one on.
8.
And so we had 4 times 2 gives us 8. Tack on a fourth one, we have
16.
8 times 2 equals 16. Put on a fifth. 16 times 2 equals 32. And we have all of those finished. Find the volume of a cube with a given side length. So if we have the volume, we know volume is equal to side length cubed. If we are given a side length of 2 meters, telling us volume equals 2 cubed. And what's 2 cubed? That's 8. What should the label on this be?
Meters.
Yeah, it will have to have the M for meters, but we've got to be careful. Meters is a length.
2 cubic meters.
Since we're talking about volume, we need to have the cube on that also. Volume is always cubed. Area is always squared. Now let's finish off this number 10. What if the volume was based on a side length of 3 feet? What would change? Side length of 3. And so we're looking at 3 cubed. And we know that's 3 times 3 times 3.
Triangle.
So 3 times 3 times 3.
18.
Not 18. Check the stages. 3 times 3 gives you 9. And 9 times 3, that gives us 27. So we wind up with 27. And the label,
Is feet.
but since it's volume, those feet are cubic. So we could put on the exponent of 3 and say cubic feet.
Yeah.
Right?
That's a question.
Stop in there. Any last questions?
No question.